Hello guys, welcome to my YouTube channel Learn to Code with Noob. Today we are going to learn some interesting facts about union types, literal types, and we will dig a bit more deeper into both of these union types and literal types and how in our day-to-day coding in TypeScript we can use these both types. Let's jump right in. Alright, so let's discuss about union types. So union types are again one of the powerful feature of TypeScript in which you can compose multiple types in TypeScript. So one of the simple example of describing the power of union types is, so for example, you want to write a function, right, which is basically is saying get key of or get value of map by key. So inside this you are basically specifying a key which has a string and the return type is string over here, right? But by the property of the map there might be a case in which this key can be in which this key cannot be found in the map, right? So I can easily say that undefined, right? That okay, this key, like I didn't find any value for the key which is passed inside the function, right? But if that key is found, then I can return that string. So I can still write the code that if, right, key is found, right, I will return a string, right, else I will return undefined. As simple as that. Now, in order for this function, like in order for this error to go, we have to define a return type, or we have to tell TypeScript that okay, this function can expect return type. It can be of a string or it can be of undefined, right? So the easy way to do it is you can do it with union type. Here comes the introduction of union type. So what union type is basically saying, now this is telling TypeScript that okay, the return type of this function can either be a string or it can be a undefined string or undefined. So one of the use case of a union type. So basically over here we composed two different types. One is string and one is undefined. We composed it into one type. So you can also say, you can basically define a type alias which says string or null, right? You can define a type interface and this can be string undefined, and now you can have a return type which says string or null. You can do that too, right? So you have a type which is string or undefined, union type. All right, now there are like lots of use cases. So some of now the other best thing about union type, or a gotcha about union type is, so for example, if you have, let's say, a type which is a, right, and you have a property 1 which is string, right, and a property 2 which is again of type string, and the same, it's kind of the same thing, you have another type, oops, you have another type. Seems like my copy and paste is not working as I'm expecting. All right, now it worked. So property 1 and property 3, right? Suppose we have like these two types, and I have one type defined which is like A and B, and this is a union type, right? Now if we have defined a union type which is union A and B, this basically means that if I have a variable of type union A and B, let's say I just initialize this variable property 1, anything property 2, right, property 3. Now why I am initializing it with all the three? I mean, I don't have to initialize all the three. Like I can just say property 1, property 2, like this won't complain because it is either A or B, right? So if I'm completing a like the properties of type A, then also this thing works. Or if I am saying like property 1 and property 3, then also it works. But if I just do this, this will complain because now A is not a union of A and B, because it should either satisfy the type A properties or satisfy the type B properties. So let's say I just did everything like property 1, 2, 3. Now if I want to print the value of property 3, I can't really do that like this. I can't do that because you can only access, like without any type checking or anything, you can only access the common properties of union type. So in this union A and B, the common property is property 1, so I can access property 1 easily, but I can't access property 2 and property 3 without type checking, right? So this is one of the gotcha of union type. So now you can easily see the power of TypeScript, in which, like, if you have to do this in a object oriented way, right, what you have to do is, like, you basically have to define a class which is union A and B, and inside that class you will have one property 1, and these both interfaces have to like extend that union A and B, right? That's what it means. But it is like a lot of work to create a very simple type. But this union type is very powerful, in which you basically just do this A pipe B or A or B, it will give you a union type. Very powerful stuff. Okay, now one more use case which is used very heavily in TypeScript world or in any of the programming language. So for example, you want to describe a UI state, right? So a UI state can contain a loading state, a failed state, and a success state. So it can contain all the three states, right? So let's say I have type which is loading state, right? And the state can be loading, right? And there is another type which is failed state. So the state is failed, and also the state can be failed. Sorry, I just had my brackets wrong. But the state also has another thing, like it basically returns us the code, like an error code, if the state is failed or if the network call is failed, let's say. And if it is if it is a success state, we obviously have a state which is success state, right? And then I have a response. When it is succeeded, I have a response. Okay, my brackets are response, and it has a message property of type string. As simple as that. Now I have a type UI state, which is basically a union of a failed, success, loading, right? So now I have a UI state, which is a union type of failed, success, and loading, right? So this is very helpful because, for example, if we want to write a function which says render UI state, now on the base of that UI state, I can easily do this. So I can just do a UI state and I can do a switch case statement, and in that I can just say UI state dot state, right? And you'll see the magic of union types. Now it automatically will give me a list of states. Okay, you can just don't do failed, success, or loading, right? And the best part is if you do suppose loading, right? So you're saying, okay, in loading, what I want to do is I just want to do a console.log, right? And in this console.log, I want to just print like UI, sorry, just dollar. So UI state dot state, right? But if, for example, you say, okay, in this loading state, I want to access UI state dot response, this won't work. So right over here, like it is checking for like what are the properties you can have the access. So for example, if I do a success now, and now if I want to do a like console.log, and if I want to access the response, now you can see automatically it is showing response and state that you can access response easily, because now I am in a success block. It automatically detects that and gives me that autocomplete thing, right? So a best way to use union types. So this is one of the use cases. So there are like lot of use cases for union types, but these are some of the use cases which I found pretty helpful, and some of the gotchas of the union types. All right, so let's discuss about literal types. So before actually explaining what are the literal types in TypeScript, I would like to explain a process in TypeScript which is called literal narrowing. So what I actually mean by that. So whenever we declare a constant, so for example, a constant can be like a pi, right? Constant pi value, for example, or I can just do this pi value, and let's say its constant value is pi value, right? Let's say that. So if you will closely look at the type of the pi value, if you will ask me what is the type of this pi value, I will say the type of this pi value is actually pi value. So if you hover over this pi value, you can easily see the type is pi value, right? But if, for example, I have a variable with a let, and I say, let's say pi value 1, right? And it has a value of pi value 1. Now the pi value 1, if you'll ask me what is the type of pi value 1, it is type string. Now what is actually different in this? So one thing we know is that constant pi value, the nature of this constant is like you can't actually add anything else, right, other than pi value, or sorry, you can't even write this value again, right, because of the constant. So you can't write the value, and the reason why you can't is because this pi value has the type of pi value. So where is literal narrowing comes in this? So what is actually literal narrowing? So if you go to this variable, right? So if we declare a variable of type string, it basically means that we can have any string value, right? That string values can be infinite, right? But when we say that we have a constant of pi value, whose actual value is string pi value, then we have narrowed it down. Like we have narrowed the string type down to, okay, that this variable can only have one string value, which is pi value, not any other value, only one value, pi value. So this is called a literal narrowing. Basically, we are narrowing the string literal from string of like any string value to string of only pi value. Alright, so now moving on to the next thing, which is string literal type. Like, what is string literal type? So string literal type is basically a literal type which you can use with other types such as union types, type aliases, type guard to make like you can achieve basically an enum kind of thing with literal types. So how you can do that? So for example, if you have a type which are days, right? So you can define days like this, like Monday, Tuesday, Wednesday, and so on, right? So when I am actually defining these literals with this pipe symbols, here is an example of a union type. So this is a union type, right? So now what this actually means is, so for example, if you have a variable of type days, now you can only define these three values. Like you can only assign these three values in this: Monday, Tuesday, and Wednesday. Nothing else. And again, you narrowed it down that the days can only be these three, nothing else, right? So it kind of behaves like an enum over here. Now we have string literal types, but as same as we also have number literal types too. Now one thing to point out is, like over here, if you see, the type of days is actually the union, like this string literal type, Monday, Tuesday, Wednesday. It is actually not string, right? The type of the days is not string, it is actually MTW, right? Now as the same thing goes with type literal. So for example, if you have like a config type, right? So this config can only have, like, I don't know, 1, 2, 3. Now if you have a variable type config, now you can only have these three values, 1, 2, 3. If you'll try to assign any other value, 5, let's say, it will say this is an unassignable value, right? So these this is one of the use cases. So for example, you can have a config, right, of anything in your code which is defined as config, and in the config you can only have like three values in there, 1, 2, 3. You can define a number literal of that, right? Instead of defining it as enum or something, you can define it like this too, right? Now moving on to the other literal type, which is of Boolean. Now this comes a bit handy when, for example, you have, like, for example, you have a function, right? And that function is flip flags, I don't know, some random function like that, right? And it has a good amount of parameters which are all booleans, right? They are like all boolean values. So the first flag is like is I don't know, is valid, or and then the next flag can be like is active, right? And there can be other flags too. So for example, there are like 5 flags over here, right? And you want to pass the value, right? So when on the calling side you will say flip flags, now is valid, right? And you will say okay, is valid, I don't know, true, and is active, false. Now when you read the code, right, you actually have to go to the definition and say okay, flip flags is valid. Okay, so true means if it is valid, and false means that it is not active, right? But you have to actually dig down into the function, right? And suppose if there are like 5 flags over here, now you are confused, right? That what is going on, like all of these flags. So the first thing is like you shouldn't write a function with all of these flags. Like you can write like better refactoring, like you can refactor this code in a very good way. And one of the way can be, for example, you can actually define a type which basically says is valid, and you can define a Boolean literal type which is true, right? Or you can say a type is valid. Sorry, you can define a variable which says that a variable valid of type true, not type Boolean, a type of true. Now if you actually call the flip flag, then you can just say valid, right? And you can also define another flag which is active, right? And now you can say active, right? I mean, you could also do like this can be obviously a Boolean, and then you can just say valid is equal to I don't know, true if that is the case, and false that is the case. You could do that obviously, but this is like one of the use case in which you can actually define a literal type like valid and active, and when you write the code with the function like this, valid and active, and if it is not valid you can also say this, right? Not valid, not active. So from the reading point of view too, it is very much readable. Like this code is very readable. Thanks for watching, guys. If you like this video, please don't forget to click on the like button. If you don't like this video, please mention why in the comment down below. Like, share and subscribe. Keep learning.